A single misplaced comma in a legal contract can cost a company millions. A small leak in a roof, if ignored, can bring down an entire building. A microscopic virus can take down global economies, even though you can't even see it. In aviation, small things can make a big impact. In aviation, this small thing is a bird. Take the Miracle on Hudson. Routine takeoff, clear skies, and then impact. In 2009, a flock of birds struck both engines, rendering the aircraft useless. It was a 77-ton glider. The only thing standing between survival and catastrophe? Captain Sully Sullenberger. He took control of the airplane and landed it on the Hudson River and saved 155 lives. It was a miracle. But in aviation, we cannot rely on miracles. Fast forward to December 2024, South Korea. A plane on approach collided with a flock of buckheel migratory birds. Both engines failed. There was a loss of 179 lives and only 2 survivors. These are not rare, isolated events. The truth is, bird strikes happen way more often than we think. In the US alone, nearly 19,400 wildlife strikes were reported at 713 airports worldwide. And globally, from 1988 to 2023, wildlife strikes have caused over 491 human deaths and destroyed more than 350 aircrafts. This is not just about birds, it's about people and safety, about trust in a global system that moves us, our families, and our economies. It must be engineered, tested, and insured. That's why bird strike testing matters, because the line between disaster and survival is long before takeoff. Through preparation, through innovation, through testing. And yet, here's the problem. Every part of an aircraft is precisely designed, but our testing methods have followed behind, being outdated and inconsistent. Many tests still rely on gelatin blocks and bird carcasses. They don't even take into account bird bones. These substitutes raise ethical concerns and fail to mimic the anatomy of the real migratory birds. The results are often unrepeatable and rarely align with simulation data. In the cost, globally, bird strikes lead to $1.2 billion in annual damages, delays, and emergency responses. So while the threat grows, the tools we use to measure and prepare have not kept up. We cannot stop bird migration, but we can prepare better. We can have better simulations, better testing methods, and have overall a high degree of accuracy. Introducing AVIA. I'm Kendyl Bourland, the Chief Marketing Officer.
I'm Rachel Wong, the Chief Executive and Financial Officer.
I'm James Kaku, and I'm the Chief Product Officer.
I'm Scott Sensiba. I'm the Chief Analytics Officer.
And we also have Luis Carlos Narino, a Chief Operating Officer. As you can see here, these are bird models. To the left, you will see theirs. It's just a gelatin capsule versus ours, which takes into account the bird structure and bone density of the birds. It's better, it's more ethical, it's realistic, it's repeatable, and there's easy cleanup.
Bird strikes cause $1.2 billion annually in damages and delays. Sustainability pressure, ethical concerns, and a growing demand for aviation testing, we have an emerging market for aviation calling for a better bird strike testing. Aerospace is over $1 billion industry in the global market. As for traction, we have our prototype of developments at low and mid fidelity simulation models. We have a creative space near the Boeing Everett plant ready for rent, as well as Boeing mentors and industry connection. Furthermore, we have our AI software that makes simulations 30 times faster than traditional simulations. We have plans for building our own physical simulation test, as well as we have performed the first we have performed our first proof of concept physical test with a 2-pound model. Physical testing will begin in May 2025.
The product we are currently developing will be scalable and will better mimic the internal bone structure of the bird. As you can see here, these birds come in many different shapes and sizes, so scalability will be critical in our product. In the initial stages on the development of our, our models, we use LS-DYNA to simulate our model designs. LS-DYNA is a finite element analysis software that have been used in various crash simulations in many different industries. Using LS-DYNA, we ran simulations on the designs that we have proposed. And then upon running the LS-DYNA models, we extract the data that we get from the test simulation, and we make a model analysis. And based on the model analysis, we propose new changes. And the changes that we have made were based on the variables in the model, such as density, bulk viscosity, and friction dynamic.
You have 5 minutes.
The simulation has allowed us to visualize how our models react to high-speed impact frame by frame, as you can see here. So far, we have over 120 hours of simulation modeling from 55 simulation tests and over 150 hours of 3D print time. To validate our simulations, we created the 3D models of the internal structure and then 3D printed them, including the molds. We then filled the molds with ballistic gel and the internal structures. As you can see here, on the left side of the screen, we have our initial product, which is a 2-pound model. But in our current prototyping testing stages, we used these miniature models that you can see here on the left in order to cut down on testing time and cost. And what I have here is the small version of the models that we have. These are lightweight and they are easily runnable in tests. As you can see here, this is the current test that we are running to validate our LS-DYNA simulation.
3 minutes.
Okay. And then this is also the 2-pound model that we do from 4-pound, a 4-story balcony to see how the impacts are at a higher speeds.
When we first started this process, we were only using gelatin models. The simulations were interesting, but they were not realistic when compared to actual bird strike data and barely even registered on the graph. Once we introduced the bone structure into the gelatin model, we knew we were on the right track. Here are 2 examples of our best fit model simulation data compared to NASA bird strike data. In these examples, you'll see how our models performed after the different modifications we made. This first graph shows one of our initial model iterations with a bone structure. It was close, but not quite where we needed to be. The second graph shows our latest model iteration with updated bone density properties, and it was a massive improvement, a real breakthrough for us. Our model data is now within the plus minus 10% range to actual bird strike data, which is the standard mandated by the FAA to gain approval to use artificial birds in strike testing. This is a huge leap forward for the aviation industry. AI Swarm Agent is cutting-edge software that at its core is a sophisticated orchestration of multiple AI agents, each specialized in specific tasks, but working together towards common goals. And our data is now being used to train AI Swarm Agent to run multiple simulations simultaneously, generating results in seconds instead of older methods that took 30 to 60 minutes to run a single simulation. This is the future of strike simulation, and AVIA is on the cutting edge of this technology.
The competitive nature of our project, for the competitive edge, we have engineering excellence, which we can replicate biometric birds that replicate real world impact properties like mass, density, and flight dynamics. We also have a competitive strategy where we plan to enter into the market using lean pricing. Furthermore, we plan
1 minute left.
Okay, we plan to use a B2B business model and charge by individual units, bulk pricing, and customer packages. These are our financial projections, and we plan to break even in year 3 in February. The growth, we plan to focus on aircraft manufacturers, secondary markets, including helicopters, military aviation, defense contractors, drones, and wind turbines. With a total of around 200 to 400 tests annually, we plan to sell 5,000 units. So,
In AVIA, we are asking for an investment of $600,000 for a 6% stake. Please consider us for the best tech venture and best trade show. From flying cars to wind turbines, this is the future we are heading towards. Let's make an impact. Making an impact together.
Very good.
I'll take questions.
You made it just in time. So now I'm going to open it up to the judges. Questions for AVIA, please.
Can you tell us more about what you're doing with Boeing in more detail? Like, how did you get it set it up? At what stage is it at? Yeah, and I think that's, I mean, it's really, really cool. And maybe that's, I gathered that a little bit more from the business plan that I read. But yeah, I would love it if you could tell us a little bit more about that.
Yeah. So our connection to Boeing, we are part of the Boeing Scholars Program. So we have mentors through Boeing working hands-on with bird impact testing. And they are on the very cutting edge. So we have worked with them in detail as this year has gone along.
So I don't know if this is a question. I still don't, I don't get it. I understand conceptually the problem of bird strikes, but I don't know who your customer, if I'm understanding it, the physical devices, they're to replicate birds, I think, but I don't know, do they like shoot these things at planes? I don't understand the testing process. Are these just rapid fire at planes to make sure they're safe? And I don't get how it mixes with AI. It's an important problem. I'm super freaked out every time I take off. I know I have 2 minutes to get above the bird height, and I'm always freaked out in those 2 minutes. So the problem I get, but I don't understand it. How would you talk to me like I'm a 5th grader that needs to understand what you're doing? I don't get it.
okay, yeah, it's no worries. We're in the midst of this, so we can explain this. So what we're working on is bird strike testing. So bird strike testing happens by a very big, basically a cannon where it shoots out a real bird. This is a freshly euthanized bird that hits they test on the windshields, they test different parts of the wing, they test parts that are very vulnerable to bird strike testing. So
just stop you right there real quick. Did you mention this and I missed that, or was that mentioned in the presentation?
We mentioned how we are testing to strike it, but as far as how they test it in the industry, that was more inferred. So
yeah, I had no idea, and I'm do they shoot out of cannons? Do they just throw them like a baseball? I have no idea. I just didn't know the context of it. So okay.
Mm-hmm. Yeah, so this is a very high speed impact test. Okay. So think of the speed of even a bullet. So at great speeds, a bird becomes even more dangerous, just like how a bullet at a very high speed would be dangerous, where it's not dangerous.
Okay.
Yeah. And the FAA, so what regulates airplane manufacturers, who is a customer, they have to run these test simulations. They have to. And then it's for the safety. They have to make sure, the airplane materials are sound. Everything, pretty much every piece of an airplane is tested. For bird strike testing, they focus on, engines and the front of the plane, the nose of the plane, where commonly birds will hit, and it will cause a huge issue while midair. So that's what they do. And they have their own testing facilities and they do that. So they have to, and they have to use some sort of bird, and they have to use also an artificial bird as well as simulation testing. That is also mandated by the FAA. So what we're talking about is that we have to, we are creating a better option for them because they have such inaccuracy, and it's a huge new area of development in order to integrate that. And then also with AI, it's a way for us to get simulations running quicker. So the airline manufacturers, they have to do the simulations, but we're able to do it quicker utilizing an AI swarm agent.
Okay. From a comment standpoint, I think it depends on your audience. If you're presenting to a general audience, I think the context will be really important because I had no idea any of that. If you're presenting to people that are in the industry, like Boeing people or engineers or flight experts, maybe you can just get right to it. I didn't understand it until just now. So like just even conceptually. So I don't know if other judges would agree or disagree. And for the context of a competition, I'm not sure. Yeah, I'm not sure. I just didn't really understand until just now. So,
yeah, Ed, I would agree in that it was pretty like technical. But I think it's a really cool business, and I think I think I'm going to kind of focus on questions to learn more about your business model and business in general, because I definitely want to learn more about that. But I would agree it was a little product and feature heavy. Tell me about your testing in May, and also how you plan to capture customers.
Yeah, so in May, we plan to continue to make our mold. So our bigger mold, this is our small one, just so that you can easily get an idea. There you go. So this is the mold. And what we plan to do in May, so we have a full size 2-pound, and then we plan to make 4-pound and 8-pound models. This is as per FAA regulations. And the 2-pound model, we recently threw it off the roof, which gave us an idea of how it worked and how it would react to hitting the ground. We will be testing it at a much higher velocity. And so this means for us building that air cannon and being able to shoot these at different pieces of metal and different things to get that data. As far as the next parts, yeah, our customers, this is where we would start with Boeing due to our partnership already and having that development in process. And then after having that established relationship, being able to serve even more airline manufacturers, as well as the secondary market, which would be helicopters, which also require bird strike testing, military aviation, defense contractors, drones, and wind turbines, which have a really big issue with birds hitting them. So with all of these, that would be our secondary market. Our primary market is Boeing, who we have a relationship with.
Where are they procuring these fake birds today, and what type of budgets do these companies have for these for procuring these?
Yeah. So for one bird strike test, it can cost between $10,000 and $100,000. This is due to a variety of factors, including that when they do test them on the actual airplanes, there are expensive materials at risk, right? And there's also a lot of cleanup, labor involved, and also they need to have a team that is set towards creating the models. So it's an expensive endeavor that they have to, by regulation, follow. So being a part of that, they already have an allocated budget for it. Improving accuracy is the cherry on top.
Awesome. Are they making them themselves today, or is there another supplier that's providing the ones without the bones in it?
No, so they provide, they make them themselves, and they have probably a team of about 5 people dedicated towards that. But again, they're worried more about the manufacturing process than actually creating these models. That's why these models have gone underdeveloped for a long time. That's why we haven't improved in this area, is because, okay, they do the testing, but it hasn't been as accurate as it could be with new technology. So that's where we come in.
Great. So what the service you guys are providing is, they've got a budget for it. Maybe that budget could even come down by better data coming out of it and having more conclusive data throughout utilizing you guys as a service or as a partner.
Correct.
Great. Well, I liked it. I was at Boeing for 6 years, so never got to see a bird strike, but.
Okay, we got 30 seconds left. Any last questions before we release AVIA?
Tell us about the grant you're applying for.
Are applying for a grant that would include, we're applying for the design partnership with ANSYS, which is the simulation software that we're using. And so this would allow us to have full versions instead of just our limited student version, which helps us to get more accurate and precise. And then we can translate that into how we 3D model the molds.
Okay, thank you very much for your presentation and your answers to our questions. We'll let you go now, and the judges will be able to make their scores.